Hello, welcome back to the channel. So today's question we are going to solve is minimum number of operations to make x and y equal. So today's problem we are going to solve. So we are given x equals to 26 and we have to make x equals to y. So basically in question there is given that we have to perform 4 operations. One is increment by 1, decrement by 1, divide by 5 if it is divisible, and divide it by 11 if it is divisible. So here we are gonna try run with 26 and we are gonna see what's the intuition of solving this. Suppose we have given 26, we have to reach 1. So we can perform 4 operations. We can make 26 25 by decrementing, then 27, and other 2 operations are not possible. As you know, 26 is not divisible by 5 and 11. So now going with this step or this level, we can see we can convert 25 into 24. We can make 25 into 26, and we can divide 25 by 5, which gonna give us 5. And the 4th operation is not possible. Here you can see that we can perform operations similarly with 24, but I'm not gonna perform this because this is not the ideal branch. So I'm basically gonna go with the right approach, which is gonna give me the clear answer. But I can tell you that at this position 26, at node 26, we have previously seen 26 over here. So we are not gonna perform the same operation with that because it will make a loop out of it, which is gonna give a TLE. So the intuition that I see over here is we have to track the previous one. That's gonna tell us that we have reached that that node earlier, so we are not gonna perform that one. So now coming with the approach of 5, we are gonna perform with 5. So I can make 5 by 4. If I decrement by 1, it's gonna be 4. I can make it 6 by incrementing 1. If I divide it by 5, it becomes 1. And the 4th operation is not gonna perform because 5 is not divisible by 11. So here you can see that we can perform the same operation with 4, but I'm not gonna show you over here because I got the right answer, which is gonna be 1. And for 6, the similar I'm not gonna perform. And as you can see that I got the answer at level. This is the level 1, this is the level 2, and this is the level 3. So from here you can see that when we are going deeper in the branch, we got the optimized answer as we reach down level to level. So the go deeper logics tell us about the BFS. This tells us that we have to move or iterate over the branch. That is going to give us the optimal answer. And for the track previous one, it's help us to not got TLE, or we are not gonna engage in a loop. As you can see that for the 26 occur over here and then occur over here. So similarly it will gonna come later on the branches on the lower level. So we are gonna stuck on a loop, so we are not gonna with that. Now coming back to the code part, here's the code. We will build up a queue, and the first element of the queue is gonna be the value that we are gonna compare with the y, and the another value is gonna be steps, or at how much step we have reached that position. So and for tracking the previous element, I have make a set called with the name of visited. Now I have initially put it with the value of x, and the step is going to be 0 because initially no steps have been performed. So this is the basic classical logic of a BFS. So when we iterate over the element, I'm going to take the value and the step out of it from the queue, and I will pop out the object or element from it. If it is already visited or traversed, we are gonna skip it. If it is and then I'm gonna mark that element visited. So if we go later on, it will gonna be skipped from here. Now if I got the value equals to y, I'm gonna return the step because it is gonna be optimized step of that level, and I'm performing the 4 operation on it. As you can see that I'm gonna push on a queue with the value of 1 with a step of 1. Each time I initialize step with plus 1 because we are going deeper. So that's the logic. If I got the value equals to y, I'm gonna return the step, and at the end if I didn't find any value, I'm gonna return -1. Thanks for watching the video. The code is in the GitHub. You can copy it from here, and do like, comment and share. Thank you.